Good day everyone. I'm Gerald M. Dueñas and I'm here to report about 2.13 and 2.14 entitled Probable Maximum Precipitation and Rainfall Data in India respectively. In design of major structures, especially in large dams, the hydrologists or hydraulic engineers keep failure rate as low as 0 in order to prevent heavy damages to life, property, economy, and in national morale. In design and analysis of structures, the maximum possible precipitation is used in order to have physical upper limit of the amount of precipitation that can fail over a specified area in a given time. In Table 2.7a, Maximum Intensity Duration Relation. In this table, we are able to determine incremental depth of rainfall in mm in various duration. So we have here first column, time in minute, second column, cumulative rainfall in mm, then third column, 30 minutes, in fourth column, 60 minutes, and so on and so forth. So, in the 0 minute, cumulative rainfall in mm is 0. In 30 minutes, we have cumulative rainfall of 6 mm. Then, in 60 minutes, we have cumulative rainfall of 18. So, in 30 minutes, we have 12 mm, and in 60 minutes, we have 18 mm. And in 19 minutes, we have cumulative rainfall in mm of 21. So in 30 minutes, we have 3 mm. In 60 minutes, we have 15 mm. And in 90 minutes, we have 21 mm. In 120 minutes, we have cumulative rainfall of 36 mm. So in 30 minutes, we have 15. And in 60 minutes, we have 18. And in 90 minutes, we have 30. And 120 minutes, we have 36. In 150 minutes, we have 43 cumulative rainfall in mm. So, in 30 minutes, we have 7 mm. In 60 minutes, we have 22 mm. In 90 minutes, we have 25 mm. In 120 minutes, we have 37 mm. And in 150 minutes, we have 43 mm. In 180 minutes, we have 49 mm. Then, so in 30 minutes, we have 6 mm. In 60 minutes, we have 13 mm. In 90 minutes, we have 28 mm. In 120 minutes, we have 31 mm. In 150 minutes, we have 43 mm. And in 180 minutes, we have 49 mm. In 210 minutes, our cumulative rainfall in mm is 52. So in 30 minutes, we have 3 mm. In 60 minutes, we have 9 mm. In 90 minutes, we have 16 mm. In 120 minutes, we have 31 mm. In 150 minutes, we have 34 mm. In 180 minutes, we have 35 mm. And in 210 minutes, we have 52 mm. In time 240 minutes, our cumulative rainfall in mm is 53. So in 30 minutes, we have 1 mm. In 60 minutes, we have 4 mm. In 90 minutes, we have 10 mm. In 120 minutes, we have 17 mm. In 150 minutes, we have 32 mm. In 180 minutes, we have 35 mm. In 210 minutes, we have 47 mm. And on 240 minutes, we have 53 mm. And on 270 minutes, our cumulative rainfall is in mm is 54 mm. So in 30 minutes, we have 1 mm. In 60 minutes, we have 2 mm. In 90 minutes, we have 5 mm. In 120 minutes, we have 11 mm. In 150 minutes, we have 18 mm. In 180 minutes, we have 33 mm. In 210 minutes, we have 36 mm. In 240 minutes, we have 48 mm. And in 270 minutes, we have 54 mm. In table 2.7b, maximum intensity, maximum depth, duration, relation. In maximum intensity, mm per hour, we have 30, 22, 20, 18.5, 17.2, 16.3, 14.9, 13.3, and 12. In duration, in minute, we have 30, 60, 90, 120, 150, 180, 210, 240, and 270. In maximum depth in mm, we have 15, 22, 30, 37, 43, 49, 52, 53, and 54. So if we are going to plot this given data, we can see it in the figure 2.24, which shows the maximum intensity duration and maximum depth duration. Probable maximum precipitation, or PMP, defined as the greatest or extreme rainfall for the given duration in a certain station. It is also defined as rainfall over basin which would produce a flood flow with virtually no risk. There are two approaches used in PMP. First is the meteorological method and statistical study of rainfall data. In statistical studies indicate that PMP can be estimated as PMP equals P plus QQ, where P mean of annual maximum rainfall series and Q is the frequency factor which depend upon the statistical distribution number of the series number of years of record and the return period. Based on the rainfall records available all over the world, we can record world's greatest rainfall. When it is plotted, it follows the equation PM equals 42.16 times D raised to 0.475, where PM is the extreme rainfall depth in cm and D is the duration in R. Rainfall in India. Rainfall measurement in India began in 18th century. The first recorded data were obtained at Calcutta in 1784, and it was followed by observations at Madras 1792, Bombay in 1823, and Simla in 1840. The India Meteorological Department, or IMD, was established in 1875, and the rainfall resolution of the Government of India in 1930 empowered IMD to have overall technical control of rainfall registration in country. According to this resolution, the state government that have the obligation to supply daily, monthly, and annual rainfall data to IMD for compilation of two important publications entitled Daily Rainfall of India and Monthly Rainfall of India. India has a network of observatories and rain gauges maintained by IMD. Currently, 2005, IMD has 701 hydrometeorological observatories and 201 agrometeorological observatories. In addition, there are 8,579 rain gauge stations, out of which 3,540 stations report the data to IMD, and etc.